everybody, I'm Miss Cooksey. Today we're going to talk about how to graph quadratic functions when they are in the standard form. Yesterday we learned the standard form of a quadratic function is ax squared plus bx plus c, and that's exactly what we've got for you today. We've got this lovely quadratic function, x squared plus 6x plus 8. Here, the a value would be 1, because we do not see a coefficient, so we know it's being multiplied by an invisible 1. B is 6, and c is 8. So we're going to use all of that information to help us graph our function. And we are always going to start by finding the axis of symmetry. The axis of symmetry will tell us our vertex, which will help us figure out the rest of our points. And then we're going to label our y and x intercepts just for fun. So let's start with x equals negative b over 2a. So b is 6, so we know x equals negative 6. A is 1. Negative 6 divided by 2 times 1 is negative 3. So we already know that there's going to be an axis of symmetry at x equals negative 3. This purple line is going to be where the graph could reflect over. We are then going to use that number to find our vertex. So we're going to take negative 3 down, and we are going to evaluate the function if we substitute in negative 3 for x. We want to find what is the y coordinate when x equals negative 3. So let's evaluate this function. Negative 3 squared is 9. 6 times negative 3 is negative 18 plus 8. Well, 9 minus 18 is negative 9 plus 8 is negative 1. HK are the letters that we're going to use to signify our vertex is going to be x equals negative 3, y equals negative 1. I'm going to go ahead and put a point at negative 3, negative 1. We now know that this is our vertex. That means both sides of the parabola are going to be the same around our vertex. So when it comes to figuring out the rest of the points, I'm going to start by putting the vertex in the middle. Now I'm going to look at the two coordinates on either side, when x equals negative 4 and when x equals negative 2. I'm going to substitute in this x value into my function to evaluate and find a y value. So I'm going to start with negative 2. It's a smaller number. That seems easy. Negative 2 squared is 4 plus 6 times negative 2. Well, that's negative 12 plus 8. When I evaluate, I end up with 0. So I'm going to go ahead and put a point at negative 2, 0. What's awesome about quadratics is we only have to do half the amount of work. This axis of symmetry says that anything on either side is the same. So if I have a point at negative 2, 0, I know I'm going to have a point at negative 4, 0. Now I'm going to look 1 point over. I'm going to look at negative 1 and negative 5. I'm going to pick a number to substitute in. I'm going to do negative 1 again. I like small numbers. They're a little bit easier. Negative 1 squared is 1 plus 6 times negative 1. So 1 minus 6 is negative 5 plus 8 is 3. So I have a point at negative 1, 3. Which tells me, because this is the axis of symmetry, I also have a point at negative 5, 3. I'm going to go ahead and connect my dots. Here is, ooh, that was not very good. Here is my parabola. Let's go ahead and fill out the x-intercepts and the y-intercept just for the practice. Well, we learned in our last video that the y-intercept is always the c value. In this case, the c value is 8. So even though we don't actually get to see this cross, we know that it's going to cross at 8. The x-intercept is wherever it crosses the x-axis. In this case, it's where y equals 0, which is at negative 4 and negative 2. Let's do one more graph. So here, I've got 2x squared minus 4x plus 6. The axis of symmetry, negative b over 2a. Well, here, b is 4, negative 4, and a is 2. So negative b would be positive 4. 2 times 2 is also 4. 4 divided by 4 is 1. This is my axis of symmetry. I'm going to go ahead and show it to you on my graph. So I know that my graph is going to reflect around 1. That was a little lopsided. Let's try that again. Beautiful. Now I'm going to take that 1, and I am going to substitute it in to my vertex to find my vertex. So I'm substituting 1 into my function because I want to know what is the y value when x equals 1. So 2 times 1 squared minus 4 times 1 plus 6. 2 times 1 squared is 2 times 1. 4 times 1 is 4 plus 6 eventually evaluates to 4. So I know that my vertex is at 1, comma 4. I'm going to go ahead and graph that. I'm also going to notice this graph is already pretty tall. I think I'm going to change how I count to make it a little bit easier. I'm going to count by 2s. Let's see if I can grab this nice little. I'm going to make this 1 and this 4. I'm going to count by 2s instead, just I think it's going to give me a bit more room. So now I'm going to take my vertex and I'm going to keep that in the middle, 1, 4. And I'm going to find the values on either side. So I'm going to try 0 and 2. I'm going to plug in 0 because that's going to be a little bit easier. 2 times 0 is 0, minus 4 times 0, which is still 0, plus 6 is 6. And I'm going to go ahead and graph 0, comma 6. Remember, I'm counting by 2s. Oh, wrong color. And because I have an axis of symmetry, I know that this graph is going to reflect. Last but not least, I'm going to look at -1 and -3. I'm going to plug in -1. 2 times -1 squared is 2, minus 4 times -1, which is 2 plus +4, which is 6. That gives me 12. I know it reflects, so 3 will also be the coordinate 3, 12. So -1, 12 is going to be up here. It's a little bit off the graph. 3, 12 is also up here, a little bit off the graph, and I'm going to connect my dots. The y-intercept is always the c value. In this case, it is 6. And the x-intercept is a little tricky here. Does this graph ever cross the x-axis? Nope. This thing has no x-intercepts. Thanks for watching. I hope this video is helpful. Be sure to tune in next time to see my video on factoring to find the solutions of a quadratic. Be sure to subscribe so you never miss a video, and I'll see you next time.